All right, so let me see if I can get this back. All right, so just based on what he went through on that, I've got my 4 major points labeled at 1, 0. That's 0 degrees, up to 90 degrees at 0, 1, which is also pi over 2. Around to 180 degrees, which is equal to pi radians, is at negative 1, 0. And 270 degrees, which is 3 pi over 2. Now, what we can use this for, all right, and then what you're going to be on your assignment, right? We said cosine is equal to the x-coordinate of all these points around the circle. Sine of theta is equal to the y-coordinate, okay? So if I wanted to know the cosine of 0 degrees, I can go to the ordered pair at 0 degrees, which is 1, 0, right? That means the cosine of 0 is 1. The sine of 0 is 0. It's also the same for 360, right? An angle that goes all the way around to 360, its cosine is 1, its sine is 0. If I want to know the cosine and sine of 90 degrees, I would go up to 90 degrees on the unit circle. And what's its ordered pair? 0, 1. So that means the cosine is 0, the sine is 1, right? The sine or the cosine of pi over 2 or the cosine of 90. Now, what we'll see on our assignment is if we go to 90 and then go all the way back around to that coterminal angle, that would be what? 700, or not 360 plus 90 would be 450. So if I went all the way around and back to 90 degrees, that angle would be 450 degrees. But its sine and cosine is going to be the same as a 90-degree angle. So if you're asked to find what's the sine of 450 degrees, what we would do is we would, remember the other day we were finding positive and negative coterminal angles? We would subtract 2 pi, or we would subtract 360 degrees, or we would add 360. So if I'm asked what's the cosine of 450 degrees, I would subtract 360 degrees to find the coterminal angle that is on this unit circle. And then the cosine is the x-coordinate, the sine is the y-coordinate. The cosine of 180 degrees is negative 1. The sine of 180 degrees is 0. The cosine of 270 degrees is 0. The sine of 270 degrees is negative 1. All right, now if I wanted to know the tangent, tangent is opposite over adjacent, which ends up being what? Was it cosine over sine or sine over cosine? My mind just went blank on it. Let me look. I believe it's opposite, so I believe it's sine over cosine. Let me double check. So it's one of those. Yeah, tangent is sine over cosine. So if I want to know the tangent of 90 degrees, sine over cosine would be y over x. It would be 1 over 0, which does not exist. What you'll notice is sometimes tangents do not exist because I'm dividing by 0. The tangent of 180 degrees would be 0 over negative 1, which is 0. The tangent of 270 degrees would be negative 1 over 0, which does not exist. The tangent of 0 would be what? 0 over 1, which is 0. All right? Now, what we want to do on this unit circle, you basically need to find the 30, 40, 30-degree, 45, 60-degree angle in each one of these around. Okay, so we've got the major ones. And based on the video we saw, we did figure out that 45, well, let's do this. Let's go all the way around and get all of our radians equivalents. All right, we want to get this angle here and here. We want to get this one here and here. This one here, here, and here. So let's get the ones in the middle first. And we can start with degrees. This one's 45 degrees. Then we go to 90. To get this angle right here in the middle, it's going to be 45 degrees past 90, which is what? 135 degrees. This middle one down here is 45 degrees past 180, which is going to be what? 45 plus 180. I'm not very good at adding in my head. Is 225 degrees. And then 45 past 270 is 315 degrees. Now, what are those radians equivalents, right? Well, we know here radians is 0. This is 2 pi. Half of 2 pi would be pi over 4. So basically, 45 degrees is pi over 4. So if I want to find the equivalent of 135, I could use the little radians to degree or degrees to radians formula, right? Which is you divide by 180 pi over, you multiply by pi over 180. So what's 135 over 180? Or you can say it's pi over 2. It's pi over 4 past pi over 2. But I'm going to do the little formula. 135 over 180 is 3/4. So this is 3 pi over 4. All right, this is pi. Then I've got to go another pi over 4, another 45 degrees. So I'm going to put 225 over 180. So that's 5 pi over 4. All right, and then this one right here is 315 over 180, which is 7 pi over 4. All right, now what are these measurements? Right here, 30 degrees. So basically these go up every 30 degrees, 30, 60, 90, then 30 more than that would be what, 120 degrees? 30 more than that would be 150 degrees. 30 more than that's 180. 30 more than that is 220. No, 30 more than that is 210 degrees. 30 more than that is 240 degrees. 270. 30 more than that is 300 degrees. 30 more than that is 330 degrees. So when you're talking about your unit circle, these are the major angles that we're going to use. Okay? And this is where you're going to get all your answers on your assignment today. Now, what are the x and y coordinates of each one of these, which is the sine and cosine? So the next thing we want to do, and I'm going to do it in a different color. I'll do it in black. We want to know what is the x and y coordinate of all these different spots. Now, we did it earlier. It did the first three, the 30, 45, and 60. We said 45 was the square root of 2 over 2. And I'm not going to have enough room to write those down. So let me figure out how I'm going to write these. I'm going to just sort of erase part of these lines so I have room to write. This was the square root of 2 over 2, comma square root of 2 over 2. The 30 degree was what? Square root of 3 over 2, comma 1/2. And the 60 was 1/2, comma square root of 3 over 2. All right, now these x and y's are going to go all the way around, except we still have to concentrate inside of our coordinate axis. X is negative over here, y is positive. X and y are both negative down here, and here x is positive, y is negative. All right, so remember what we said. He said these match up. All right, so this one's going to match up to this one in that the x coordinate is, right, the x coordinate is going to be 1/2, except right here, this is x equals negative 1/2. So this is going to be negative 1/2. And then this is still a positive square root of 3 over 2. All right. This is the 45. All these 45s, if I go all the way around on all these 45s, it's always square root of 2 over 2, comma, square root of 2 over 2. I just have to worry about my positives and negatives. So this one right here is this x value is in the negative. So this is going to be a negative square root of 2 over 2, comma, square root of 2 over 2. Down here, this 45, this x coordinate is negative, the y coordinate is negative. So this is negative square root of 2 over 2, comma, negative square root of 2 over 2. Then this one right here, the x is positive, the y is negative. So this is square root of 2 over 2, comma, negative square root of 2 over 2. So now, on those 45s, I know the sine and cosine of 45 degrees, 135 degrees, 225 degrees, and 315 degrees. The cosine is the y or the x coordinate. So the cosine of 45 degrees is square root of 2 over 2. The cosine of 135 degrees is negative square root of 2 over 2. All right. The cosine of 5/4 pi radians is negative square root of 2 over 2. The sine is the same thing all the way around. So let's just continue filling in this chart right here. This one matches up with this one right here. So this x coordinate that's a negative. So that's going to be negative square root of 3 over 2, comma, 1/2. All right. This angle is going to match up with this angle down here. This is going to be a negative square root of 3 over 2. And then the y coordinate is going to be negative also. Negative square root of 3 over 2, comma, negative 1/2. Now this angle is going to match with this one up here where the x coordinate is the 1/2 and the y is the negative 3/2, right? The x goes back a shorter amount, goes back to there. That's a negative 1/2. And then it's the y is negative, so that's going to be negative square root of 2. These two, if I reflect it across, same thing. The x coordinate is going to be a positive 1/2 this time. I'm moving positive in the x, negative in the y. So this is going to be negative 3 square root of 2. And then here, mirrors across from this one. The x is positive to this point right here. So this is going to be the square root of 3 over 2. And then the y down here, this is a positive and this is a negative. This is going to be negative 1/2. So there you have the entire unit circle. So now if I have this unit circle, it's very easy to find the sine and cosine of any of these particular angles. All right. If I wanted to know what's the sine of 7 pi over 4, sine of 7 pi over 4. Well, where's 7 pi over 4? It's right here. It's just 315 degrees. So what's the sine of that? That's the y coordinate, negative square root of 2 over 2. What's the x coordinate? That's the cosine. The cosine is square root of 2 over 2. So if I want to know the sine of 7 pi over 4, I go to 7 pi over 4. Right there's that y coordinate. All right. If I want to know what's the cosine of 3 pi over 4, where's 3 pi over 4? 3 pi over 4 is right here, which is from this position, 135 degrees. The cosine of 3 pi over 4 is that x coordinate of negative square root of 2 over 2. All right. Now it's easy to Google out a copy of the unit circle if you hadn't written it all down. It should be in the book also, but that's very helpful for what. So what they're going to be doing, asking your assignment today is, well, let's look. Let's see, where is, let me just pull up the web assign real quick. And this is going to be assignment 4.2, view. So I'm just going to sort of run through and see. All right. It wants to know exact values. All right. Let me see if I can stop this share. And then let me share. All right, so this is one of the problems. It's going to be, it gives you that this point is at 4/5, comma 3/5. So I don't care about the angles right now. It just wants to know the sine of theta, cosine of theta. Well, sine is the y coordinate, cosine is the x coordinate. So I know the sine is 3/5, the cosine is 4/5. Now, cosecant and secant, you just got to flip those fractions over, right? They're the inverses. So I would just flip that over. This would be 5/3 and this would be 4/5. Now, how do I find the tangent? Well, tangent is the sine over the cosine. So I would put 3/5 over 4/5 and simplify it. Then the cotangent, I can just flip that around. All right. So you'll see that's a couple of the problems. Next problem, find the point on the circle that corresponds to the real number t. So it wants to know if we go to pi over 6. Well, if I go back to this and I look at pi over 6, pi over 6 is, well, we didn't end up filling in all the radians, did we? Pi over 6 is right here. Pi over 6, this is pi over 3. 120 over 180 is 2 pi over 3. 150 over 180. Basically, you just have to put the degrees over 180. 5/6 pi, 5 pi over 6. 210 over 180. 7/6 pi. 7 pi over 6. 240 over 180 is 4/3 pi. So this is 4 pi over 3. 300 over 180 is 5 pi over 3. And 330 over 180 is 11 pi over 6. So what was the question that it asked? No, that's the wrong one. It says, what point is associated with pi over 6? Well, here's pi over 6. Here's pi over 6, this one right here. So this is the point. Square root of 3 over 2, comma 1/2. That's what they're looking for there. All right. What's the point? What's the point associated with pi? All right, then it asks for the sine, cosine, and tangent of pi over 6. Well, there's pi over 6. The sine is 1/2. The cosine is -3 over 2. The tangent would be 1/2 over that. Then you simplify, which is basically simplifies to 1 over square root of 3, or that's square root of 3 over 3. Evaluate sine, cosine, and tangent. 5 pi over 6. So I'd go to 5 pi over 6, which is right here. So the sine is 1/2. The cosine is -3 square root of 3 over 2. The tangent would be this fraction over that fraction. All right. Several of those. All right. Now, once you get past those, it's going to say evaluate the trigonomic function using its period as an aid. And then it gives 19 pi over 3. Well, 19 pi over 3 means it's going all the way around. That's like more than 360. So what I need to do is I need to subtract. You can either change it to degrees and work with it that way, or to get one of these angles from 19 pi over 3 is I subtract 2 pi with it from it once and to see if that gets me back within this range. If not, I subtract it again. Then it will get me within this range, and then I can just pick out the ordered pair there or the sine. He wants to know the sine of that. Negative. Remember, negative angles go back this way. To find a coterminal of a negative angle, you add 2 pi. So I would add 2 pi to a negative angle. And then that should be it. So that's basically what's going on. So really, a picture or a copy of this unit circle would be very helpful, I'm sure. If I just Google a unit circle, I can find one. There's one right there. So it's not very hard to find. If you want to pull up a unit circle on your phone or whatever to use around with it. But that'll be it. I'll go ahead and activate 4.2. So we're going backwards a little bit. And then that'll be it. And I can stop the share of this. And then I can try to figure out how to, there,